Okay, good evening, all of you. And yeah, today's topic is fraud detection using Excel. So, as you know, there are many corporations around the world, both financial and banking companies, as well as other non-financial companies also are said to be losing billions of dollars due to the fraud. In transaction processing. Of course, you have credit card frauds, you have accounting frauds, you have many areas where fraudsters are trying to take out the money from the company's cash, for example, or create fake false invoices and try to capture the take out the money, steal the money, etc. So there are many innovative ways fraudsters are using. So today's session, what we will be doing is we'll focus on some techniques that are used by auditors and forensic accountants to detect fraud in a given set of transactions. Okay. For example, just to give you an idea, let's say, for example, this is a set of transactions that we have. Okay, these are the vendor payments made by a company in a certain year. Okay, in a certain year, if you see, there are different dates of the transaction. Okay, there are different invoices that have been processed, and there's a payment date given, and there is a certain vendor number. Vendor number basically represents the supplier's number and the amount of payment. So normally it looks like a transaction. Now, as a analyst or as an auditor, if my purpose is to detect fraud, there may be some of these invoices which might be fraudulent invoices. So what methodology can I apply here? Right. So this is a sample data, and I'm going to show you different techniques through which we can detect potentially fraudulent transactions. So before that, let us try to understand something called fraud triangle. Okay, why would anybody conduct fraud? Okay, for that we say that there are three aspects to be present for a fraud to happen. Starting with there must be an opportunity for the it could be an employee, it could be a manager who is in a position to conduct a fraud. He should have an opportunity to perform fraud. So probably maybe he's in the position of handling cash, he's in the position of approving a certain invoice, he's a position of a vendor selection. It could be in any which ways. He must have an opportunity. Now, just because there is an opportunity, okay, which of course even we all face on a day-to-day basis, doesn't mean that we go ahead and do fraud, right? So there must be uh, a point of convincing for the person to rationalize the fraud. So, for example, rationalization means I will do this fraud, but I will find a justification to myself to convince myself that I can, do this fraudulent activity. All right. For example, I might think that, see, I'm not the only person who is doing this fraud. So everybody are doing, so I'm also doing. See, that is one way of you rationalizing your own act. Okay. Or secondly, you might also say that, see, there are people who are, stealing crores of money. So I'm only, stealing, let's say 100 rupees. So it's not a very big amount. So, so I'm basically rationalizing it. Or I might also say that I'm rationalizing because, maybe I am in a need for the funds now. Okay. I am in a need for the funds. And because I have a need for funds, I will take the money now and I will replace the money later. Right? You might say that also, correct? So that means before anybody finds out, I'm going to give back the money. So I'm not stealing, rather I'm borrowing. So you might say that also. So there must be an opportunity, there must be a rationalization, and there must be a need. Correct? A person must have a need. So when these three aspects are present, only a person goes about doing fraud. Okay, there are many ways frauds happen. So let's not get into that discussion today. So our discussion today is focusing on the fraud detection. Okay, so is there any other aspect other than this? Yes, there is another aspect of fraud prevention. Fraud prevention is more of a planning that you do such that the fraud doesn't occur at all. These are the internal check systems that you might have. But today we will be focusing on fraud detection. So what is the difference here? In fraud detection, transactions are already happened and the files are with me. Based on looking at those files, my responsibility is to find out if there is a fraudulent transaction that might have happened. It's most of a It's more of a post-mortem kind of a scenario that you are following here. That is fraud detection for, right? So fraud detection generally is associated with what is called as anomaly detection. So what is an anomaly? Anomaly is an abnormality in a given set of data. Okay, so our focus would be today to look at few tests that we can perform where we will find out the anomaly in the data. All right, so you will understand that more when I start working on it. So let's take a first scenario. Okay, let's take a first scenario. So in this business, let's assume that I'm an expert in this business, or rather I've been in this business for long, or maybe I'm an auditor who has seen all kinds of transactions around. So I say that in this business, the billing amount, the payment amount, invoice amounts are generally in odd values like this because of some pricing, that structure the company has, or maybe the taxation rate, etc. So there cannot be transactions with the multiples of 1,000. Okay, if there is any transaction with multiples of 1,000, for example, I see here, you see there is a 1,000 rupee transaction. So this is an anomaly here. This is something which has a potential to be a fraudulent transaction. So all I have to do is I need to call for that filing. There are thousands of files here. I can't be doing audit on each of the files. Instead, I will identify these anomalies and ask for those files only. All right. So how do we identify that? How do we use Excel to detect this anomaly? Okay. So I will say I'll add a column called tester. In here, I'm going to say, see, my idea is to get all the values which are in multiples of thousands, correct? So that means if the transaction is of 1,000 rupees, 2,000, 3,000, 4,000, 10,000. So if there is a number that is divisible by 1,000, that means it must be a fraudulent transaction. Okay. So I'm going to use a function. I'm going to use a function called mod. Okay. What is mod function? Mod function basically takes two numbers, divides the first number by the second number, and gives the remainder of it. Okay, for example, you will see that now. The first number I'll give, which is 2353.72, comma, the divisor, that is from which number do I divide that? I will say from 1,000. So this will give me the remainder. Just know when you divide 2353 from 1,000, what do you get? You get the remainder as 353, right? Yeah. So same way, for example, here, 951 you're getting. When you divide 8,951 by 1,000, you get a remainder of 951. Now imagine this, if you divide 1,000 by 1,000, you'll get the remainder as 0. So that means wherever the remainder of this number when divided by 1,000 is 0, that must be a value of a multiple of 1,000. So which is what I want to flag. Okay. So what I'll do is I'll rewrite this formula now. I am going to say if mod of E2 when it divided by 1,000 is equal to 0, then you flag the transaction for me. Otherwise, say OK. All right. So this is how I'm going to copy this. Now you see the transaction that is a multiple of 1,000 has been highlighted, right? Let's just find out how many flag transactions are there. I'm putting a filter and I'm saying sort to A to Z. So you see we have got around 6 transactions that have been flagged. You see the transaction amounts are 1,000, 7,000, 1,000, 3,000. These are all multiples of 1,000. Okay, so these are the files which I will go further to. I'm not saying they're fraudulent transactions, but I think these have a higher potential of becoming fraudulent transactions. All right. So that is one way of anomaly detection. I hope you understood what do we mean by fraud detection now. You have a set of transactions and you're trying to detect the anomaly by, using your expert opinion that in this business, multiples of thousands may not be possible as a transaction amount. Number one. So now let us take the discussion forward. Now let us look at one more kind of an anomaly. Another kind of anomaly that you might find, in businesses is, see, these are the same invoice database. So somebody who wants to do a fraudulent transaction, okay, would basically be looking at creating a false invoice, a fake invoice, a duplicate invoice. So for example, just to give you an example, look at these two transactions. See, you see these two transactions. they're exactly same. The vendor number, the invoice ID, payment date, invoice date, the amount, everything is same. Now, what is the objective of the fraudster to create such a fake invoice? He's thinking that, see, I'll create a fake invoice, and one of the invoice, of course, is a fake one, and I'm going to, misappropriate the money from that invoice, the amount of the 6,647, I'm going to misappropriate. And the probability that this file will be called for audit will be very less, number one. Secondly, even if they call, there is a real invoice in that number. So even if the auditor cross-checks with the vendor will confirm that yes, there is an invoice number with 103 and 6647 was the payment that was made on 29 December. So what is the probability that the auditor will call for both of them? So if the fraudster is thinking like that and creating a fake invoice, which is supposedly has been a practice, amongst many companies, it has been observed. All of these are, I'm not saying this, these are all practices followed by auditors over a period of time. So now I need to identify the fake transaction here, fake invoices. So which is a fake invoice? If at all the invoice is getting duplicated with the exact invoice ID, exact invoice number, exact vendor code and the amount, if all the four are same, okay, so then it must be a flag transaction or an anomaly. So I'm going to put a test function here. So how do I flag this? See, I'm going to use a function countifs, where I'm going to ask Excel to count the number of times a certain invoice ID, invoice date, vendor code and the amount will appear. Okay, if that number is more than one, if that exact all the four appearing for more than one time, then it is an anomaly form, correct? So how do we do this? Let's say if, okay, we'll put the if later. Countifs, I'm using the countifs. Remember, count function counts. Countif function counts based on a one condition. Countifs, an S, counts the number of an appearance of a certain thing based on multiple criteria. So what is my first criteria? Okay, it's asking for criteria range. My first criteria is this column A. Column A. In that column A, I want you to search for this invoice ID. So what does this give me? This will give me how many times this invoice ID is being appearing. Correct? You see it's appearing three, 4 times here, which is no problem, but the dates are different. So they are not fake invoices. Anyways, then I'll give second criteria, which is my invoice date. And in the column B, what should I count for? In this case, I want you to count for the day. Then the vendor code. Okay, count the number of times this vendor code appears and the amount which is in E column, how many times it is appearing. So if this will count and tell me how many times this, say, a transaction with same invoice ID, invoice date, vendor code and the amount appears. So you see this particular combination appears only once. Like this, if you see here, you see this part, it's saying that this particular transaction with the invoice ID, invoice date, vendor code and amount is appearing twice. Sometimes it might be 3 also, right? So all I have to do is put this in if condition so that the flag happens. If this number is more than 1, flag this. Otherwise, click OK. Okay, that's it. So we have identified the transactions with the invoice ID, payment date, vendor amount being the same. And by the way, this test is called same test. It's a very famous test, by the way. Okay, same test. So let me see how many transactions we have got. So I have almost how many? 4 plus 4, 8 transactions are there which are appearing multiple times. So these are my anomalies based on this logic. Okay, hope you understood that. For referring the formulas, please go back and watch the video wherever I will enter the formula once more time. Plus, I'm going to give you this document in the link. In the description also it will be given. In the Google Drive also it will be available for you. Okay, I'm moving on to the next test now. Okay, the next test is something like this. Again, see, these are all expert approaches. Somebody from that business will know these logics. Okay, for example, if I am in a certain industry, I know the kind of practices followed by fraudsters in my industry. All right, so I'm going to be basically following that. So another test is something like this. If the vendor frequency is less than 3 times, that means, let's say this vendor number is 43. Generally in my business or in this business, it has been observed that uh, if I have a vendor in a year, I would have done transaction more than 3 times easily. So if at all there is any vendor who's done transactions for less than 3 number of times, it could be some fake vendor that is created by the fraudster. Correct? So you just create a fake vendor, make one small payment or something and take the money, and the vendor doesn't do any transaction. It shouldn't happen. Okay, so I know that. Plus, if the cutoff amount is 5,000 or more, that means a vendor appears only less than 3 times here, less than or equal to 3 times, and the amount of transaction is 5,000. So if that is so, I guess it could be an anomaly. So how do I put an Excel function to get that? So similar to what we did countifs, I'm going to put countif here because there's only one condition I want to test for. See, watch this. I'm going to say countif, the vendor frequency, okay, for the vendor number. So this will basically give me the number of times this vendor code is appearing in this. For example, this vendor, 43rd vendor, is appearing almost 24 times. Okay, so like this, you can click. If there is any of this vendor who is appearing for less than 3 times, see this vendor, he is only appearing for 2 times. So potentially, but this is not the only condition. I also need to put another condition of 5,000. So let me put this in if condition. If condition, if count of that vendor is less than or equal to, let's say 3. Okay, I'm going to freeze it, less than or equal to 3. Okay, this is checking one condition. We need to check two conditions, right? So I'll put one more condition, but it has to be such that both the conditions must be satisfied. So therefore, I'm going to use a function called AND function. So AND means one criteria matched. What is the other criteria? The other criteria is amount, which is this amount should be more than 5,000. Yeah, let's freeze that also. So when both the conditions are matching, you flag that for test. Otherwise, you can say okay. Okay, that's it. Accept it. Done. Let me check one more time. All done. Right? Now let's check. I just copy pasted this. Okay. Now let me filter this to see the flag transaction. You see this transaction. This vendor, for example, vendor number 11, is appearing, let's see. Okay, vendor number 11 is appearing only 2 times. See, that's one part. Okay. Secondly, the amount also is more than 8,000. So more than 5,000. So therefore, I say this is a fraudulent transaction. Similarly, vendor number 8 appearing for only less 2 times and the amount is more than 5,000. So therefore, these are my flagged transactions. Okay, so that's one. So I hope you're following this. Let me take the next test. See, the next test in the same lines of thought is something like this. It's a very silly mistake. Sometimes fraudsters also are fools. When their payment date is before the invoice date. See, generally payment happens, or maybe in this business, we know that we never make a advance payment. So it's always that invoice is generated after that only, or at least the same day we make the payment, but never before an invoice has been raised, we make a payment. So let's say we know that. Okay, so I have the invoice date, I have the payment date. So I want to see if the payment date is before the invoice date. So you can simply put a if condition, if the payment date is less than the invoice date. If the payment date is less than invoice date, okay, so I'll say it is a flaggable transaction. Otherwise, it's an okay transaction. So it's a very simple formula. Okay, so you see this transaction itself is a fraudulent transaction. You see, your invoice date is 29th May, but payment happens on 26th May. How could it that be possible, right? So let's see how many transactions we got here. So I have 3 transactions whose invoice date is after the payment date, right? So this is another anomaly detection or fraud detection that you've done. Okay, let's look at one more. See, I'm just going continuously. hoping that you will pass wherever required. You will also work. Anyways, you are being given the data file. So you will practice. And of course, if you have questions, you can always come back to me. All right. So now this case is again, as an expert in the business or as an auditor in this business, I know that we have never made any payment on a weekend. We have not made payments on weekends. So if there is a transaction that happened on a weekend, okay, that means it must be potentially a fraudulent transaction. So how do I get that? How do I get that? So for this, I'm going to use a function called weekday. I'm going to use a function called weekday. What does weekday give me? Weekday basically gives me, if I type this, okay, it gives me 3. So what does it mean? It means that if you take Sunday as 1, Monday as 2, Tuesday as 3. So 29th, sorry, did we select 29th? No, 26th May is a Tuesday. 3 means Tuesday. Okay, that is by default. Now I want to change the order. So I'm going to use the return type as 16. 16. So what is return type 16? There's a description here you can read. Numbers 1 is Saturday through 7 is Friday. That means Saturday is taken as 1, Sunday 2, Monday 3, etc., etc. Friday is 7. Okay, there is a reason why I'm doing that. I will tell you in a while. So now it is telling me 4 is the value. That is, this is the 4th day. So if your Monday is 1, okay, sorry, not Monday, Saturday is 1, 4 means Saturday, Sunday, Monday, Tuesday, correct? It's coming as Tuesday, right? So we got these values. Now here, what is my criteria? I want to check whether this is a weekend or not, correct? So generally, based on our logic, when we give the return type 16, I'll show it to you one more time. 16 means Saturday is 1, Sunday is 2. That means if any of these values are less than or equal to 2, either 1 or 2, that means it must be a weekend, correct? So let me put that condition. If weekday of this cell, okay, is less than or equal to 2, I would say it is a flaggable transaction. Otherwise, it's that means it's a payment done on weekend, which is not possible in my business. All right. So let's find out now if we have got any transactions like that. Okay, great. So we have these dates. You can cross check the calendar. 21st November 2020 must be a Saturday or a Sunday. All right. So this is another way that we can go about detecting the fraudulent transactions. So far, whatever we have done, okay, are basically thumb rule methods used by experts in the business, okay, used by auditors who are experts in this kind of a business, who know that, okay, in this particular industry or a business or the company, typical frauds happen. Fraudsters follow these processes of creating fake invoice, duplicate invoice, processing payments on weekends, multiples of thousands not possible, correct? So these are expert approach. In addition to that, there are some basic statistical approaches that can also be used here. The next 1 or 2 examples I'm going to discuss with you, test examples, will be based on statistical understanding. A little bit of statistical understanding is required for it. I'll try my level best to make it simple for you. See, again, this is another set of transactional data that we have here. You see, there are organization numbers given. That is probably the vendor number. There are, I think, some 7 different kinds of vendors. And in each of the vendors, there are 3 types of departments that we have. And the account number also is there, some 6 account numbers, and the amount is there. Okay. Now, I will focus on the amount right now to start with. I'll focus on the amount right now. And I want to find out the outliers in this particular set of transaction. Now, what is an outlier? Outlier is, when you present your data in a frequency distribution, those values which are at the extreme end of the table, they are basically outliers. Say, for example, if we take the average age of this classroom right now, let's say there may be some students who are 20-year-olds, there may be some of you who are 30-year-old, some of you may be 40, some of you may be 50 also, correct? No, but average age of this group is, I know it's around 25 to 30, correct? So that means most of you will be in the 25 to 30 range, correct? Whereas there may be some of you who are like 18, 19, so they are outliers. There may be some of you, probably I'm also including. I'm probably quite older than you, so maybe my age is an outlier number, correct? So like that, in this data, I want to find out the outliers. So how do I find the outlier? For that, we perform something called a Z-score test. Z-score test. I'm trying to make it sound less statistic, but I will also give you the statistical logic later. But right now, how auditors use this test, I will tell you. They calculate a Z-score using the X, which is this observation. I'm looking for outlier in the amount, no? X minus mu. Okay, mu basically means mean. Let's say mean. We'll keep it simple. Mean. So what is the average of this? So X minus average of this divided by the standard deviation. Here is standard deviation. Okay. How do you calculate all this? I will tell you. How do you calculate mean? You can calculate the mean using the average function. I'm just giving average of the column number D. Okay. Then how do you calculate standard deviation? Again, you can use the function stdev and give this column. So let me do the calculation. All right. So this is mean and standard deviation. So now let me calculate the Z-score. Z-score. So X minus the mean. Okay. So for mean, I'm going to use the average function of this column. Okay. Divided by standard deviation of column D. Okay, so that's it. Enter. So it gives you a Z score of 1.25, etc., etc. Okay, different values are there. Now here, see the thumb rule. As I told you, thumb rule is if Z score is between minus 2.5 to plus 2.5, okay, then it is normal. Else it is an outlier. Let's assume like this. This is a non-statistical way of explaining, but I can explain in statistical way also. Okay, let's look at one small graph here. I'm using standard normal distribution. There's a website where I can show you an interactive way. Yeah, I'm sure some of you would be familiar with this. Okay, so you watch this, Z value here. Okay, if I move the Z value to, let's say, 2.5, somewhere here, close to 2.5, this part. Okay, 2.5. What does this say? It says that there is 99.38% of the data falls in this range. The remaining part is your outliers. I'm kind of saying 0.62 percentage. Okay, so it's a thumb rule. It's a thumb rule. You can decide the percentage. Say, for example, you want 95%. So you can move this. Move it to come to something like 95%, maybe somewhere here 95. So you see 1.65. So you can keep the Z score. So if you want to consider the top 5% to be the outliers. Okay. So similarly, you can also look at minus 2.5 here. Minus 2.5. You see this part is the outlier, 0.68%. Okay. So basically that's what your Z value is doing. Okay. Anyways, we just have to put this formula here where I want to see if this number is less than minus 2.5 or more than 2.5. Okay. So I'm going to say use the function R. Please keep yourself muted. I'm going to use the function R, ORR. Okay, R will basically test for two or more conditions also, but in this case, two conditions. Even if any one of them are also as matching, it will give me the answer as true. So for me, there are two conditions. Okay, one is whether the Z score, this score is less than or equal to minus 2.5. Okay, what is the second condition? Whether the Z score is more than or equal to 2.5. Okay, so if both of these are matching, if both the conditions are matching, okay, it is telling false now. That means both conditions are not matching. That means Z score 1.25 is between minus 2.5 to 2.4. Therefore, no flag. Okay, But if I copy this somewhere here, if I can find it, I can find a true. Yeah, in this case, see, you see 2.54 as Z score. So this I assume, is an outlier for me. Okay. So let's put that in a if condition. If this condition is true, give me flag. Otherwise, give me okay. All right. So that's it. So all the transactions will be flagged now. Okay. See, I got these many transactions with the values either, of course, in this case, all are above 2.5. Even if they are less than 2.5 also, it would have identified. Okay. So this is another way for you to identify the flag transactions. This is statistically used method. The same method can also be understood in another way. Okay, I'll show you that. So something called IQR, interquartile range, So basically, this data, when you present it in a kind of a graph or something, okay. So when you present like this data, okay, you imagine that I divide this data into 4 parts. Okay, part 1, part 2, part 3, part 4. So this we call as quartile 1. This is quartile 2, of course. Okay, this is quartile 3. Okay, so the data that falls between Q1 and Q3, this is called interquartile range. Interquartile range. All right. So we are going to first calculate that for this data. Okay. And then I will tell you how we can use that to detect fraud. Okay. So firstly, let me calculate the quartile 1 of the data. Then I will calculate the quartile 2 of the. How do we do that? Excel gives you a function called quartile and give the data and type 1 because you want the first quartile. Okay, 25th percentile. Similarly, use the function quartile, give the data and give 3 to detect the third quartile. So my data, by the way, just to give you a perspective, let's see what is minimum. Okay, minimum of this data is this. Maximum of this data, maybe maximum I can paste here for better view. Maximum is maximum of this data. Okay, so you see minimum is 11, maximum is 1746. The 25th percentile is 531 and sorry, this is quartile 3 is 824. You with me? So let's calculate the IQR for this. What is IQR? Interquartile range, which is nothing but Q3 minus Q1. Q3 minus Q1. All right. So Q3 minus Q1. Okay, this is the interquartile. This is the distance between Q3 to Q1. That means almost 50% of your data falls between this range. So now using this, what we will do is we will calculate an upper limit for the data. That means beyond which any value falls, it's an outlier form. So how do we calculate upper limit? Upper limit is calculated like this. Whatever is your Q3, the highest value, plus 1.5 times of IQR. Okay, that is your upper limit. Let me put that as a formula. Q3 824 plus 1.5 times of interquartile range. So this is basically upper limit of the. So any value in this column, any value which is above 1263.561 is an outlier. Okay. Similarly, you can calculate the lower limit of the value also. That would be whatever is Q1 minus 1.5 times of interquartile range. Okay. So Q1 minus 1.5 times of interquartile range. So any value below 92.3624 is also an outlier for me. So now that I know both the outliers, let me perform the test. Okay. What is the test? If this number is more than 1263 or less than 92, you have to flag me. Okay. So let's say I'll use the function R because there are two conditions, any one of which has to be satisfied. So if this number is more than, or rather we'll start with lower limit. If it is less than the lower limit, first condition. Second condition is again this number is more than the upper limit. Okay, if both the condition, any one of the condition matches also, you give me true or false. So you see, sorry, we have to freeze this now. We have to freeze this. I'm sorry, I did not do that. All right. So you see, I don't see any true at all. Surprising. Achha, I got one here. So you see 39.79, which is below the lower limit. So let's put this in a if condition. If any one of these conditions is true, give me flag, otherwise give me okay. All right. So let's try to see if we can. Okay. So we have around 7 transactions whose the upper whose values are less than the lower limit or higher than the upper limit. So this is another way of detecting the outliers. This can also be worked out. This can also be worked out using in a graphical manner. Okay. So what I'll do is I will take this data and I will put in something called box and whisker plot. Box and whisker plot. Don't get carried away. It's the same test that we have done here. I'm going to generate it in the form of a plot and I will explain the plot also. So let's do one thing. Let's go to insert, and here in the charts here, you have a histogram. Okay. In the histogram, select box and whisker plot. Okay. Okay. Now I have a blank here. I need to select the data. Let's select the data. Some default value is taken, remove that. So add. So series name, maybe amount. Series values is this column. I selected all the values and I'm giving it. Okay. Okay. One second. Just hold the line. So let's not worry much. I'll select the entire column, insert, histogram, box and whisker plot. Yeah, that's it. All right. So we have the box and whisker plot here. Just for your reference, I'm going to insert the data labels. Okay, data labels here, so that I'll be able to explain to you all these values, how they're looking like. Okay, first of all, this line, the bottom line of this shaded portion is your Q1. Q1 value is how much? 530.66. Is that your Q1? Yes. Yeah. Similarly, this part, the upper border of this shaded line is your Q3 825. Okay, there's a slight difference here. And of course, this is the median, so you can ignore that. You see, this 1207 is your upper limit. Okay, 1002. What is this upper limit? This is nothing but whatever is the Q3 plus 1.5 times of the IQR. This shaded portion is your IQR, right? Imagine 1.5 times of that, and I'm increasing the above the Q3, I'm increasing the limit. Similarly, 1.5 times of the interquartile range is pasted here, and below that is your lower limit. Okay, so this is another way for, and all the values falling above the upper limit and below the lower limit are all my outliers, possibly fraudulent transactions. All right, so this is one. And one last thing, using the same data, I can generate a histogram. Let's select a histogram. Okay, so histogram is another pictorial way of detecting the outliers. So I'll just make some small modifications here. I'm right clicking on this format axis. Okay, I'm right clicking on the x-axis label, format axis. I'll say the number of bins. Right now it is 23 automatically taken. I'll change it to 30. Okay, the overflow bin, I will say 1500. And the underflow bin, I'll keep it as maybe 100. So that means my definition of an outlier is if any of the values are above 1500 or below 100 are my outliers. Okay, if I do that, you can see that here. Okay. Yeah, you can see that I found these last set of transactions these are my below 100 values or above 1000. So those are my outliers. Of course, it doesn't give you the detail of the transaction, but when I'm presenting this as a report, when I'm trying to explain how many fraudulent transactions, how many anomalous transactions that we found out, we could use a histogram to make a presentation. That's the idea here. Okay. So that's basically another, statistics based test. With that, let me move on to the next test and the final and the most important test for you, which is Benford's law. Benford's law or Benford test. Okay. So let me explain the logic first. Okay, 1 minute. Let me explain the logic first, and then I will show you how we can incorporate that in the table here. Okay, so firstly, Benford is a mathematician who has tried something, some kind of an experiment on majority of the data in the world. Okay, for example, you can take the population data of the world country-wise, and you can pull out the first digit of each of the transactions. For example, each of the observation. For example, in this transaction, what is the first digit? 3, correct? And what is the first digit here? 1. See, it doesn't matter what is the number, how big, how small is the number. It is just the first digit you're pulling out. 2, 1. Are you following the pattern here? So like this, if you pull out the first digit, the number of times that first digit appears, being 1, that is your first digit being 1, that probability will be, the probability that your first digit will be 1 will be almost a 30.10%. This is true for any large data which is a result of a random generation. For example, you can't take your Aadhaar number and take all the first digits of the Aadhaar number and say I will apply Benford's law. It doesn't work that way, right? It's so that has to be a number. Like for example, transaction values, right? There's no logic why the transaction values are like this, correct? There is no dependency of each transaction here with each other, right? But if you take the, let's say, Aadhaar number, for example, telephone number, there's a pattern. If my number starts from 9 something, that means it is in particular year, particular location has been issued. Okay. Similarly, the probability of the first digit being 2 will be around 17.61%. See, these are all standard numbers given by Benford. All right. In fact, I have a method for you to get these values also. Okay. You can see the formula I have written here. Log of 1 plus 1 divided by d. D means the digit. Okay. So let me take the log of 1 plus 1 divided by the digit 1. Okay. You see, 1 second. 1 plus, I forgot. Yeah, 30.10%. Okay. So similarly, 17.61%, 12.49%. So what does this mean? It basically means that in any data that you're giving me, the out of 100, let's say if you're giving me 100 data points here, there will be 30 of them which will have the first digit as 1. There will be 7.92% of them which will have the first digit as 5. Okay. Now, Benford's law has been tried and tested on many data around the world by researchers over a period of time, and Benford's law always proven to be all correct. Now, my objective here is to find out how many times these transactions are appearing here and what is that percentage here. That is what I want to do now. All right. So let's do that now. Let's say, for example, first let's count it. Let's count. Okay. For counting, I need to first get the number, no, first digit. Okay. First digit. So let's get the first digit here. Let's get the first digit. Guys, I got scared. Please stay silent. I think I will mute all of you. Okay. First digit is something like this. I'll use the function left. Okay. I'm using the function left. Left is a text function that basically pulls out the number of characters from the left side of content in the cell. So I'm giving this particular cell and I'm telling give me the first character there. Okay, so of course it is giving me 3 here. So similarly I can copy paste. So I have all the first digits extracted. Let me put that as a number. So okay, so you see I have the first digits of each of the transaction amount I have taken here with me. Okay, now I have to count how many times 1 is appearing here, correct? So how do we do that? Simple, no? We can say count if, okay, give this range, if it is equal to this. Simple. So there are 989 times 1 is appearing here. That means out of, I have a total of around how many transactions? Almost 3,142 transactions there, 3,000 plus transactions there. Out of that, 989 transactions have their first digit as 1. And maybe I'll copy this. There are 534 transactions who have a value of 2 and etc. etc. Okay. Now let me calculate the frequency percentage of each of them. See, first of all, let's take the total. There are totally 3,141 transactions. Out of that, 989 is the percentage of transactions with digit 1. So what is the percentage here? 31.49%. Okay, similarly, can I calculate for this? 534 divided by 314, 17%. Is it close to this number? Yes. Of course, you can't get the same number. Okay, we'll fix that in a while now. So you got this now? So all you have to do is this matching with this? But before I put a graph and see that, okay, one way that we can work on is we can set an upper limit for the Benford's probability. Okay, let's put an upper limit here. Maybe I'll put it here. Upper limit and lower limit. So how do we put an upper limit, lower limit? We will use this formula. You see here, whatever is the probability that I have here, basically it's proportion. It is a confidence interval limit at 95% confidence interval for the proportions. So proportion plus 1.96. 1.96 is the Z score value for 95% confidence interval. Square root of whatever is the probability into 1 minus probability into n. Okay, so this formula I will put it here using the plus function. Okay, let's see. Probability plus 1.96 multiplied by square root of probability multiplied by 1 minus probability multiplied by the n. N I have is 3,141. Maybe I'll freeze this. So this will give me the upper limit for the transaction. Just give me a second. Okay, sorry. There's a small change to the limit here. Okay, whatever formula we have put, you can say plus or minus 1 divided by 2n. We just need to add that. Okay, just give me a sec. Okay, so that means here I need to plus 1 divided by 2 times the n. Raise it again. So this should be the formula. Sorry guys, sorry. Just okay, sorry. I have to just missed one small divided by symbol here, and then everything is all right. Yeah. Okay, let's put this in the formula, plug it the formula here. So I've done that already, you see. I'll probably write it one more time, okay? Just watch this. Whatever is, I'm just writing this formula here, upper limit. Probability plus, okay, 1.96, which is a Z score value for 95% confidence interval, multiplied by square root of probability multiplied by 1 minus probability divided by the n, I'll freeze the n. Okay, bracket closed, 2 bracket closed, plus 1 divided by 2 times the n. Okay, so this will give me the upper limit of 31.72 percentage. Okay, I think everything is fit, so I can copy paste this. So you see, this must be the upper limit at a 95% confidence. Okay, that means there may be 5% error here and there, but ideally it should be 31.7. I'll copy the same formula and paste it here. Okay, so instead of plus, I will use minus symbol. So that will give me the lower limit. Okay, so the lower limit must be 28.48%. So now I have the Benford's probability, upper limit for it and lower limit for it, and I have my actual frequency. Now all I have to do is I want to ensure that this frequency is well within the upper and the lower limit. Okay, so how do we find that? We'll put a small graph for this. Okay, we'll put a graph for this. Let's put a graph for the upper limit. No, for frequency, I'll put a graph. Okay, let's insert a column graph, a simple column graph I'm putting. All right, so these are my values. Okay, now I will put the upper limit and the lower limit as the additional series here. Okay, so let's add the upper limit. Series values are this. Okay, click OK. Again add the lower limit. Series values are this. Okay, click OK. One more thing that I want to do is I want to format the data series. Okay, where I want to say I want the, okay, wait, let's do it like this. Go to the chart design, select the chart type, select combo. So here the frequency, let it be in column, the upper limit make it a line, lower limit also you can make it a line. So it will appear like this. Okay. Okay. Click OK. Now see, this is quite easy for us to detect now. I'll tell you what we are trying to detect. What I'm trying to see here is all these values, whatever the peak of these columns that I have now, should be between the upper and the lower limit. Okay, that means the first digits are as per the Benford's suggested probability. For example, the fourth transaction you see here, the fourth transaction, the data label, if I take, it's around 7.86 percentage. You see 7.86 percentage, which is below the lower limit. See, fourth digit, it should be at least 8.64%. But in this case, I have 7.86%. So this is a potential, transactions first digit, or those transactions with the first digit 4 probably have the fraudulent transactions, probably. So I don't know, I'm just clicking on 4 now. So now you see I have these many transactions. I have around 248 transactions. So these are the transactions that I would like to verify first up. This is an anomaly. Potentially, I'm not saying these are fraud. This could be a potential anomalous transactions. Okay, so this was basically how you can apply Benford's law. Benford's law is been backtested multiple times, and I myself have tried it on, let's say, world population data. It's very easy. You can download the world population data and work on it. World GDP data or any random number that you generate, you can try this. Benford's law always works. Okay, don't know how it works, but mathematically it's a possibility, and you see that result here also. Correct, these numbers have not been made up. These are actually the real data that has been taken from some data source, and it was not prepared. This is not a data for Benford's, but you can still see the pattern, no? So most of the observations will have the first digit being 1, will be almost 30% of the data. So, and wherever we see any anomaly like this is a fraud for us. All right, so that is Benford's law. Benford's law also, additional suggestion is this: there's a probability given for second digit also. Correct, so you can go ahead and explore that more. So thank you so much for joining. I will share this file with you, and if you have any questions you can ask me. Okay.